Let's see if we can get a quick video. That's going to be quite a few videos, I'm thinking, in chapter 5 here. This chapter is just loaded with information, and it's called Grading with Lasers, GPS, and Other Specialized Equipment. Later on, it'll get into the other equipment, such as GPS, mounted on heavy equipment and things like that. But just starting out from scratch, they're telling us to be careful about where we set up our laser. Uh, there's 3 factors they want you to consider. You want it in a safe place so it don't get run over. Second, the setup point should offer good coverage of the job site, not behind the dirt pile. And third, if the grades you'll be checking will continue to get lower, set the laser so that the beam will hit the receiver low on the rod. Why is that? They're saying about knee high. So this will give you more room because you can see if your grades are getting lower, the receiver will keep rising on the rod. So you don't want to run out of rod. So do the reverse if you'll be working uphill. In other words, the grades are once the grades are getting higher, the a receiver on the rod will get the readings on the rod will get lower. Uh, so it's always the opposite. If the grades are going down, the readings are going up. Keep in mind that wherever you set the laser unit, it must be higher than any place. So we're going to start out with parking lots and apartment complex. This is parking lots are kind of interesting to build. But let's see what they got to say. Starting out, what is a swell? Well, it's a low spot on purpose. Where that at the bottom of that swell, there's probably going to be a storm water catch basin. Its swells are shaped sometimes like a oval, and with the lowest point being where the catch basin is, and and then the pipes, as we saw in the other video, uh, of the stormwater pipe being installed. That there were arrows pointing in the direction that they wanted the water to flow, and there were elevations, slot elevations, so that you would be able to figure out, where the swell was, how much you wanted to cut, and all of that. So, and right here, there's a sentence that I like. It says, "Where deep cuts are required, oops, set a 2 or 4 foot lath with the cut or fill marked on it. This is faster and more practical than driving hubs that will be excavated later. Don't bother sweeting. The subgrade will be faster." A Swede setup is, well, it's like 3 metal lath, really, and they're adjustable in height, and there's just a pole sticking up with a crossbar on top. And I'm going to just, I've never, ever been around them, never used them. But they say once you get the hang of it, it's good for large areas like large parking lots. I mean, big parking lots. But anyway, on 317, page 317, take time and you can go read about Swedes. And I think on page 53, there is a picture of a set of Swedes. They're really good for setting 2 on each side of the road and then adjusting the center one to be in line. When you sight, you'll just see nothing but one little round spot. Then you'll know you're on your high point out there, and you measure that distance. It's kind of like an imaginary string line. Really, it's kind of like stretching a string line across the road and measuring down from it. So anyway, layout. Let's see, the grid. Okay, what is it saying here? Okay, it says when rough grading is finished, you may want to establish a grid. Such a grid, all of you know, is just like grid lines, grid paper. Uh, they're useful on large areas like football parking lot that have a few islands, you know, like where there's grass or flowers or a tree or something. And the grid lines should intersect about every 25 feet. Lay out the same grid lines on the site and drive a hub at each intersection point of the grid. Don't bother setting the hubs at right now. That will come later. Figure out what the elevation should be that's proposed, what it should be at each hub so that the entire area will drain evenly from the highest point to the lowest point. So it goes on about the grids, but I'm going to, you can read that. We will be getting into grids on our way here toward the end of this, actually the end of this, uh, sorry, lost my flow here. Anyway, let me just show you rather than sit here and talk about it. I hope I can uh, get us over to the other camera. Let's see if I can get on the, I got two things going here. I have a video app and then I have the thing you're looking at that's coming out of that video. So let's see. There. Now, no, yes. And it's a little bit dark. I got about as much light. We'll talk about this later. But I want to show you a series of, let's, they're pages from some things we'll be tackling later on, but it's going to explain this grid thing, I think, much better than we can with words. Let's just look at this one first. Now, this is coming from a grade plan. Uh, as you can see, it has, I don't know if you can see, but right down here, it's an example of existing conditions grading, and it's not to scale. Now, these are your existing contours. Here's 105. Look here, this V, when the V's are the direction they're pointed, that means it's like the water will flow down this opposite the way they're pointed, and you can look at this 105, 104, 103 and tell that it does get lower as we go down. Now, we have established some, like this elevation 105 is all 105, and then it comes back on 106. We know about contour lines. This is a hill right here, 108, 107. You can see that. This topographical configuration right here is called a saddle. And if you notice, this is like, if you were looking at it from a profile view, there'd be a hill here and a hill here. And they call those saddles, this configuration. Now, existing grades. Okay, let's throw some desired proposed stuff on here and look. Now, we have these gridded. This is the same picture we just looked at, but it's been gridded right there. Now we're seeing it with grids on it. These grids are, I'm not sure. Let's see. Does it say? It's calling for 100 foot between grid lines. Now, the tighter they are, the more accurate. The more frequent spaces of guidelines, the outer nodes. Any intersection is called a node, and we'll get that on this next piece of paper. Of this layout are now beyond the limits of disturbance and will now have the same elevation in the existing proposed. So look at this. This right here, this is a pad, and for maybe a finished floor to be set on here. But right now, it's a pad. And it's telling you this is a finished grade, this solid line. It's telling you this pad needs to be 107 feet. So if it's got to be right here, look at this grid line right here. Let me peek. Hold on. This is 108, I think. Yeah. And the house pad is 107. So right here, we're going to have a cut. So right here, we would mark it. We would mark cut 1 foot right here where my pencil point is. And this would be at the intersection of E5. You see there? That's how they're noted. This node is E5, and that's where you find it. This right here would go back, still E, but it's E4. It's moved over here, and again, there's probably no earthwork to be done here. Just cutting off this top knoll here, and then the rest of it right here is going to be, as you see, is 106. So that's going to be some fill work in here for this pad to be built. And then at the same time, we've got to keep up the drainage. So one more, and then we'll move on from the grid, because we're going to get heavily into this kind of stuff now and even in the estimating course. So all of these, if we got out and measured, we know the proposed grade and we know the existing grade. So now what we're doing is we're going to calculate or do a cut and fill analysis using this thing. So I'm not going to go in any order here, but let's start at this node right here where the arrow is. That's E7. So we'd go E and 7. So at E7, we're looking at an existing grade of 106.80 and a proposed grade of 106.60. So this existing grade is just a wee bit higher here, so we're going to have to cut this just a little bit. What is that? 2/10, I guess. So that would be marked at somewhere here as like cut 0, 2. So put a stake there, and you can measure, even on a map, you can make up your own scale. And if this telling you these grid lines are 100 feet apart, you can just what's called interpolate and kind of make up your own scale. But we'll get into that later. But look at all of these nodes, they're points on this grid all over here. Now, so look at this C5 node right here. Its existing is 103. Proposed is 106.25. 103, that's almost 4. So that's a couple of feet that we're going to have to cut. So imagine this, that some of these will be fills, some of these will be cuts. If your cuts are positive, that's up to you, as long as you keep it the same. And your fills are negative, you would say, forget what it's called. It's we would average all these pluses and minuses. When we get into takeoffs and volumes of earth, we're going to deal with pluses for cuts, and we're going to deal with minuses for fills. So you may have a cut of 2 feet, and then you may have a fill. So that'd be a minus, +2, a fill of 1. So that'd be +2 minus 1, and then you may have a +2 minus 3. So you add those as a plus or a minus. Once you get through, if your finish averaging is a plus, then you're going to have to cut, right? You're going to have to cut. So you're going to have some dirt to get rid of, right? If the final average is a fill and we don't have the dirt here, we're going to have to bring dirt in. And that's when you get into estimating how much dirt and things like that. So that's just a really quick look at a grid, and it's not to be worried about right now, but we will be getting there shortly. This is something that, if we can see it, I'm going to show you when as we move through this first part of this chapter 5. All right. So they said that we talked about the grid, talked about it. So once you get it established, you do what I said. So, but they're saying if it has several ridges and swell for drainage plus curves, planters around the perimeter throughout may be faster to swede it. And again, I've never used swedes. A lot of folks, and you know, that's old school stuff to me, even. And so I don't know the value of them. A lot of times for large areas, they say they're really good, and for roads, they're really good. But I don't know. I don't see it. So if look at the, let's see if we can get out of this. If the grader is equipped with sonar and slope control, sonar, yes, like sonar with string lines and things like that, and slope control, the grade setter must compute the percentage of fall for each area and let the grader operator know what slope to dial in, which is GPS. Very few intermediate stakes will be needed, and as we all know. Now, an apartment building or industrial pads are big, and they talk a little bit. It doesn't have much to say about it, but what you're going to get is you're going to have a lot of contour lines, and you're going to have a lot of storm water to put in, and you're going to have an unfinished floor of the building, like I showed a while ago, and a pad elevation. Be sure you always use the pad elevation because the finished floor is built on top of the pad. The pad is to keep the finished floor up off, you know, the grade line so that water will drain away. So if it's, here's a case right here. Assume the pad is 300 feet long and 250 feet wide. Then it talks about scraper operators holding a grade there. So you're going to have to chase them, you set some stakes up. They used to set things they call guineas, and for motor graders, that was the little blue. That's when the word blue top came around. The little 2x2 by about 6 inch stake that goes in the ground, and the grader. They had little whiskers, they called them, sticking up. If they were blue, that was finish. That was subgrade. If they were red, that was finish grade. So you start out as a guinea chaser. They say you're the guy that, as the motor grader goes across top of these, he needs to cut right to the top of it without disturbing the hub. But if he does, it's your job to put the hub back. It's quite a you have to be in shape to keep up with the grader. Sometimes they paint the cuts, you know. Sometimes they'll say it's on grade, and that's a circle with an arrow through it. They may, and I'm talking about a can of spray paint. It may say cut 3.2 on the ground, you know. And the grade checker in those days just kept the operator informed of, does he need to go down or up, you know, and he did it in any way he could, and that was 1 or 2. So stay ahead, painting cut and fill symbols on the ground. You're not going to see much of this anymore, but it's stuff we need to know where we come from, and give us a better appreciation of GPS. So he's saying here, remember we talked about the boots, we talked about the hand level and things like that, but when you're using a laser rod, it's what it's telling us is we don't need that with the eye level. Now, sometimes it's just easy to go back to the hand level, but we're going through these calculations. It's good exercise to think about where our elevations are going to be. So let's start out with this example right here, and I'm going to call your attention now, if we can read it, to an actual what I drew up to. This is called the illustration for the example on page 96, and that's where we are. So looking at this example, it said if you need 2 inches, that's 0.17 feet, or that's 0.17 foot of asphalt and 6 inches, that's a half a foot, of aggregate for our parking section, the 3 elevations marked on the lath might be AC, that's asphaltic concrete, 135, and that's the finished asphalt. That's where they want it, 135. That's what you need to read when you're finished. So the asphaltic base, the finished aggregate, is 134 because you take that 135 and you subtract the thickness of that asphalt right here, and it brings you down minus 0.17, as the book says. And then that puts you into the asphaltic base elevation of 134.33. As you can see, I think you can see, yeah. No, I'm not there. 134.83 to the top of your base, 134.83, and that was be 135, the finished grade, and 135 minus 0.17 equals 134.83, which is your top of aggregate. And the subgrade would be 135 minus the 2 inches or 0.17 foot of asphalt, and minus the half a foot or 6 inches of aggregate, yielding a result of 134.33. That's your reading. When you get there, you keep that and mark that on your lath. So that's the reading you're looking for when you're looking for the subgrade. That's where you want your subgrade, as you can see up here. Now that's the example, and it's a simple example. You just took a reading. This is what they want the finished grade to read. So to get that, we're going to have to subtract the thickness of the asphalt right here. We're going to have to subtract the half a foot from the aggregate, and that's going to bring us down to 134.33. So when you're on grade, your rod, your receiver should be at 134.33 on your grade rod. Now, here's a couple of things. Using a laser level on a road project. So the elevation, these are the 3 things that you're going to need on a lath on a road project. You're going to need a ditch elevation, you're going to need a shoulder elevation, and you're going to need a center line of the subgrade elevation marked on each lab at each station. And it let's see, what does it say? Each time the grade is checked at a station, the grade setter can see that the elevation he should have on the survey rod. So it's been marked on the lath. Now, let's move on over here to these 2 situations. One involves a cut. One involves a fill. Now, this is a little bit different from what we just got through doing. So let me go through it with you. And I'm going to flip this, I think. I'm going to do, no. I'm going to just stick this over here. They're hard to read, but this is like me thinking out loud. So let's take this situation of a cut. The reading on the rod, as the book says, this is me setting my rod on a hub, and the information on the hub says cut 0.7, and that's going to be to the asphalt, I think, but it says cut 0.7, and then you want to check the finished subgrade. You want to find finished subgrade, what that should read. So here's how to do it. Set your survey rod on the hub that beside the stake that says cut 7. Set it on the hub in question and subtract the cut And the road section depth, that's how deep when you've calculated asphalt, aggregate, and maybe curb and gutter. That's the depth you're going with the road section. So you you would you would take this cut, and that cut is leading you to finish grade for your asphalt. And then there's an addition, there's an additional 0.75 road section depth to accommodate whatever needs to be done on the subgrade, maybe bringing in borrow or whatever else. But so subtracting this cut right here from the reading you got right here, this is when you set your rod on the hub and move the receiver until you got a laser beep, solid beep, and it read 350, you would subtract the cut and you would subtract this road section depth of 7.5. And when you did that, you would end up with 2.05. I don't think you'll be able to see it very well, but right here is the reading I got when I set my survey rod on this hub in front of this stake that's told me to cut, that there was a cut of 0.70 right here. So this is the reading I got when I set my rod here. So the book tells me to subtract the cut, and that leaves me with 2.80, and it tells me to subtract the section depth, which is 0.75. Now, this is the reading I want for my subgrade, 2.05. Now, look at, I don't have a drawing for the fill, but let's go to the fill. That's a cut. Now, if the surveyors have a fill rather than a cut to the finished grade, the fill must be added. In other words, this would be a plus if they were talking. That's the only difference. This would be a plus. Now, stay with me here. And it says the fill must be added. Where did it say that? So, okay, to finished grade, the fill must be added to the rod reading, which is still the same, 3.50. Well, he just, to me, just gave things away, but this is going to come out level, I think. We use the same rod reading. That's like when I set it on the rod here, I got the same, on the hub here, I got the same reading of 3.5. Where's it saying that? If we use, oh, there it is, 350 with the fill of 0.7 and a 0.75 road section, the rod reading for the subgrade should be 3.45. This is how it came about. We started out at 3.5. We added the cut here. Here we subtracted it when it was a cut. We added the fill here because it's a fill. And then from that, we subtracted uh, the section depth, which was 0.75, and we came up with 3.45. Now, that's on the subgrade. That's when I get to subgrade. What's interesting to me here is when I take this subgrade reading that I'm looking for, 3.45, and I subtract it from the cut subgrade reading of 2.05, if I subtract those two, I get 14. And notice we have a cut of 7 and we have a fill of 7. So with those two readings, what we're in that 14, that's accommodating those sevens kind of cancel out. And though the readings are different, I feel like the road would be the same. So anyway, that's enough of that. And let's see, what have we got? Where is the, let's see. This is a good statement. Remember, a road or parking lot section is the thickness of the asphalted concrete, that's asphalt, plus the aggregate between the finished grade and the subgrade. So in our case, at the very beginning, it was 0.17 feet, 2 inches, and it was a half a foot for aggregate. So on a large road unit, the laser must be moved several times, so they're saying that it's probably just as quick to use a hand level. I'm not sure about that. Let's see. All this is talking about when it's all said and done, you got to figure you get your elevation for aggregate, add the thickness of the aggregate to be placed on all the subgrade elevations. That go ahead and put this stuff on your that we just got to talk about on your lat. So when it's time to put aggregate down, when it's time to put asphalt, you'll already have a reading. So this is just an example. If the subgrade marking says 345 and there's a half a foot of aggregate to be placed, then add that. So to 3.45. So you would change your aggregate. This would be your aggregate, top of your aggregate right here. So I'm going to try to get us out of here and to this right here. This is going to get a little bit more complicated. So I'm going to stop the recording right here, and then next video we'll take up this trench work. We've already touched on that a little bit with the video of the guy when he got rain and stuff. I like that video. And then there'll be an extra. Oh, you haven't seen it yet. I don't know, uh, or maybe you have now that you when you're reading this. I forget the present and the future sometimes, get them confused. Maybe that's getting a little older. So anyway, that's enough for this this video here.